So in this video, as part of Galois theory, we're going to derive the quadratic formula. Recall we have this discriminant, b squared minus 4ac. So if this discriminant is bigger than 0, then we have two distinct real roots. If it's 0, then we have one root, a repeated root, and if it's less than 0, we have no real roots, but we do have the two complex roots. Okay, so we want to derive the quadratic formula, and so we're going to use this, something we're aiming for, right? So we want to get a 4ac in here, and we see a c, so we're going to multiply the whole thing by a 4a. And so in here we're assuming a is not 0, right? If a was 0, then the solution would be obvious. It would just be, if a was 0, then we could just move the c to the other side and divide by b and get x equals negative c over b. Well, supposing b is not 0, right? This is the case that a equals 0 and b is non-zero. But the case we care about is the case a is non-zero. In this case, we can multiply everything by a, and because we're multiplying by a non-zero thing, we're not going to add any more roots to it, right? So we get 4a squared x squared plus 4bx plus 4ac equals 0. Okay. Now, what we're aiming for is we're aiming for something of this form. So, because we have a plus 4ac, we want to subtract this from both sides, and then we're going to add b squared to both sides. So 4a squared x squared equals plus 4bx. So we add b squared, so add b squared, and then we subtract 4ac. We're adding b squared to both sides, so we get b squared here as well. And when we subtract 4ac, we get minus 4ac, which is just a discriminant. But now we notice that this side, we can factorize it. And it's definitely not obvious that we can do that. We're multiplying by 4a, so there should be an a here. So we multiply by 4a here, so we get 4a squared, then 4ab, and then 4ac. Okay. Turns out you can factorize it like 2ax plus b squared. Obviously 2ax squared would give us this term, b squared would give us this term, and the cross term, if we multiply these two together, then we get 2abx, but then we get it twice, right? Because we have this like a plus b squared is like a squared plus 2ab plus b squared, this 2 here. And so we get this as a factorization. And now we're almost done. So we get, from here we're carrying this down. We can just square root both sides, right? So we get 2a plus b equals the square root of the discriminant as well. Okay, recall that's always plus or minus, right? So we could have positive or negative square roots. And so we subtract b from both sides, we get 2ax equals minus b plus or minus square root of the discriminant. And then we divide through by 2a, because we said a is non-zero. X is equal to minus b plus or minus square root of the discriminant over 2a. And we're done. This is the quadratic formula. Thanks for watching.